All right, today we're going to be going over factoring a little bit, along with graphing, completing the square root method, and quadratic formula. Those are the 5 different ways that you can solve a quadratic equation written in the form ax squared plus bx plus c equals 0. The big question is, when should you use which tool in the tool bag? So think about factoring, graphing, completing the square root method, and quadratic formula as being part of the tools in your tool bag, and you have a certain tool for each thing. So for example, you could undo a 1/2 inch bolt with a wrench, a socket, a crescent wrench, or maybe even a pair of pliers. Which one would be the hardest to do that with, to take off a 1/2 inch bolt? Well, the pair of pliers would be the hardest. What would be the easiest? Well, if you had an impact wrench, right? So we're going to use the right tool for the job depending on which is easiest. So I'm going to try and teach you that as I go through this video. So first of all, those are the 5 different methods, and those are going to be reviewed on this thing. Take good notes on this part and make sure you can use all of the different 5 methods. The first method we're going over is factoring. This is best used when in this equation, ax squared plus bx plus c, so you have a quadratic, which is the squared part, a linear term, which is the number with just the x, and you have a constant, which is just the number with no x's. So when this equation has an a value of 1, in other words, when there's not really a number in front of the square, that's when you want to use factoring if possible. The other key there is, can you read it backwards? And the way we read it backwards, remember, is to say what multiplies to be the last number, the c value, what multiplies to be the c value, and either adds or subtracts, depending on that sign, to be the middle value. So in this case, we're going to say what multiplies to be 45 and subtracts to be 4. That's right, it's 9 and 5. So ask yourself the question, what multiplies to be the last term, and then either adds or subtracts to be the middle term. So we're going to multiply to be 45 and subtract to be 4. That's 9 and 5. We've set up 2 sets of parentheses, x and x, that's the square root of the x squared, and then 9 and 5. Those are the factors of 45 that will subtract to be 4. Then you fill in your signs. The way you fill in your signs is, if this sign is a difference, the last constant is a difference, then the signs have to be different, 1 plus, 1 minus. The way you know which one goes where is the bigger of the 2 gets the sign in the middle. So 9 is bigger than 5, therefore 9 gets the minus and 5 gets the positive, because they had to be different, and the bigger one got the sign in the middle. We then set each factor equal to 0 and solve. Boom, that's my answer. Okay? All right, because if you say x minus 9 equals 0, you're going to add 9 to both sides. If you say x plus 5 equals 0, you're going to subtract 5 from both sides. The next thing we're going to go over is graphing. This is only easiest when it's already graphed. The points that the graph crosses the x-axis are the solutions. If it doesn't cross, then there are 2 imaginary complex solutions. So let me go over those. So if we have a graph here, and it crosses at -1 and it crosses at 3, the x-axis, so you're only paying attention to this x-axis. If it crosses the x-axis at -1 and 3, then your solutions are -1 and 3. It's super easy. You just look at the graph. The problem is sometimes it will not cross, so it entirely lies above or maybe below the x-axis. If that's the case, then you have 2 imaginary complex solutions, and we'll get into those a little bit more as we go along with the quadratic formula. Okay. The third type is completing the square. Now, when is this easiest? When should we use this tool? Well, we usually use completing the square when the a value is 1 and b is an even value. So what you're looking for is the x squared, number in front of the x squared is just a 1, and this x value is an even value. If that's the case, I don't care what the c value is, I'm going to put it on the other side of the equation. Notice when we factor, we want to set it equal to 0. In fact, in every other type except completing the square, we want the equation to equal 0. That's something that you should put in your notes. Always set the equation equal to 0 except when completing the square, or I guess doing the square root method. So those two methods don't set it equal to 0, but all the rest of the methods do set it equal to 0. So completing the square and square root, you're going to set it equal to the constant and then solve from there. So what I do to use the completing the square method is I take half of the linear coefficient. So that's half of the b value. So half of -6 is -3. Square that value. This is the completing the square. You take half and square it. You take half and square it. So I'm going to take half of -6 is -3. Square it gives me 9. Whatever this value is, you add to both sides, both the constant side and the side of the quadratic and linear terms. So now I have x squared minus 6x plus 9. Where'd the 9 come from? Half of 6 squared. And I also add 9 to the 11. That gave me the 20. Now, the left side will be what we call a perfect square trinomial. That's why we complete the square. So the square root of x squared is x, the square root of 9 is 3, and the sign in the middle is minus. It's all in one set of parentheses squared. So the way you factor a perfect square trinomial is take the square root of the first term, square root of the last term, sign in the middle, put it in one set of parentheses squared. And when we complete this square, that's why we call it that, that's what we will have every time after we do this half and squaring it. Now at this point, we take the square root of both sides. That's x minus 3. To do the square root of 20, we need to factor tree that down to simplify it. So 4 and 5 make 20, and then 2 and 2 make 4. Now if I have a pair of 2's, I can bring that out, but I'll have to leave the 5 under the root. We've done a bunch of those. Okay, at this point, I simply add 3 to get the x by itself. That gives me two answers, 3 plus 2 roots of 5, and 3 minus 2 roots of 5. And those are my answers. The next type is the square root method. This is easiest used when there is no bx term, in other words, there's no linear term, or when the equation is written in one set of parentheses squared in the form x plus h. So in this case, look at the two examples. In this example, we have a set of parentheses squared. And so anytime I see this set of parentheses squared, I know that the square root method is going to be the easiest. I want to get the constant over here and that parenthesis by itself. So in this case, I got to get rid of the 2 and the 5. I get rid of the 5 first by adding it to both sides. That gives me 32 over here. It gets rid of the 5 over here. I still have this 2 in front of this parenthesis. Make sure you divide that out before you take the square root. Always divide out whatever's in front of the parenthesis before you take the square root. So I'm going to divide out the 2. That gives me 16. Now I have x plus 3 in parentheses squared equals 16. Take the square root of both sides. That gives me x plus 3 equals plus or minus. The square root of 16 is 4. This one comes out of the square root because it is a perfect square. Now I simply subtract 3 to both sides. And I end up with -3 plus 4, that gives me 1, or -3 minus 4, which gives me -7. Another type is where there is no x term. So notice there is no bx term in this. This isn't 5x, it's just a 5. So because of that, I just want to get this square by itself. So again, I'm going to get rid of the 5 and the 3. I'm going to first subtract the 5, that gives me 11. Then I'm going to divide by 3. That gives me x squared equals 11 thirds. Leave things as fractions, leave them as improper fractions, and then just simplify. As I take the square root of both sides, the x is just going to come out of the square root as an x. And then I'm going to end up not wanting to leave that square root of 3 on the bottom. So square root of 3 times square root of 3 is 3. That will be on the bottom. And then I'll have to times the top by square root of 3. Square root of 3 times square root of 11 is square root of 33. That's my answer there. The last type is quadratic formula. You use this method when a is not 1. So if there's ever a number in front of the square, this is the easiest way to do it, is to use the quadratic formula. Or if it doesn't factor. So if a is still 1, if there isn't a number in front of the square, we'll still do it with quadratic formula if it doesn't factor. So let's go through a couple of those. First of all, this is super important to have in your notes. This is the quadratic formula. It's negative b plus or minus the square root of b squared minus 4ac over 2a. Make sure you remember that and have that written in your notes. At that point, I'm going to just substitute in the values for a, b, and c from right here. The number in front of the square is the a, the number in front of the linear term is the b, and the c value is obviously the c value. The key here is make sure that you're equal to 0. That c value will have the wrong sign unless it's equal to 0. So make sure you set up your equation equal to 0. Bring the c value back over before you use the quadratic formula. Okay, let's go through a couple of those. So here we have 2x squared plus 3x minus 4 equals 0. I'm like, I'm not going to factor this. I'm just going to use the quadratic formula because that 2 is in front of the square. Now this may or may not factor. In this case it won't. But most importantly, this is just the easiest way to do it. This is the right tool for the job when there's a number in front of that square. Notice it's already set equal to 0. The constant is on the same side as the quadratic and linear terms. That has to be in that standard form before you can set up the quadratic formula. Setting up the quadratic formula now. I'm going to take the opposite of positive 3, which is negative 3, plus or minus the square root of b squared, that's 3 squared, which is 9. 3 times 3 is 9. Minus 4a, that's the 2, c, that's the negative 4. So I'm going to take the square root of b squared minus 4ac. Well, 4 times 4 times 2, negative times a positive times a negative. What's a negative times a positive times a negative? That's a positive. 4 times 4 is 16, doubled is 32. 32 plus 9 gives you 41. It's all over 4 because it's 2a. So 2 times 2 is how I got that 4. Don't forget it's over 2a, not just 2. At this point, I have really two answers. It's negative 3 plus or minus the square root of 41. Now you may say, well, why didn't he factor tree that down? Because it doesn't. That is a prime number, so it's not going to come out of the root. Now, some of the questions may ask you to round to the nearest hundredth, and you can do that on your calculator and then use a decimal here and take negative 3 plus the decimal equivalent of that, which in this case is about, I don't know, 6.6-ish, because square root of 36 would be 6, and square root of 49 would be 7, so maybe it's about 6.5-ish, I don't know, 6.45 would be my guess on that square root, but you can do it on your calculator and get it exact if you need to round to the nearest hundredth. And then that whole thing is still got to be divided by 4 if I do that. Same thing over here. Over here, it just doesn't factor. There isn't two things that times to be 2 and add to be 7. So therefore I do 7 plus or minus the square root of 49. Where did the 49 come from? 7 squared. How come this is positive 7 instead of negative? Because it was negative in the equation. It's positive here. It's the opposite of b, meaning opposite sign of b, plus or minus the square root of b squared, minus 4 times a times c. A is 1, c is 2. 4 times a times c. That's negative 8. 49 minus 8 is 41 again, all over 2. How come it's over 2 this time? Well, it's 2 times a. A is 1. Now I have 7 plus or minus the square root of 41, the whole thing over 2. Again, you could write that as a decimal if it asks you to round it to the nearest hundredth. Now, here's the ones I want you to do for today. There's only 10 questions. Show all your work. Make sure you show all your work on this. Okay, so here I have the different questions, 1 through 10. So I'm going to kind of let you write down these first 5. So hit pause right here and write down these first 5. And then write down these 5, 6 through 10. Hit pause if you need to and write these down. Use the appropriate method and show all the work for solving these equations. Thank you.